Good afternoon, and welcome to the panel session on EU regulation. Today, I got two very esteemed panel members, Mr. Professor Angelo Baghini. He has been the professor at the university, PhD. He has authored over 200 papers and written 2 books. He had been a chairman of Senelec. So as far as the EU regulations are concerned, he has not only seen how the regulation came into from front seat, but he had been at the table in formation of regulation. So, and he has been secretary of Senelec since 2007. He has his own consulting company specializing in transformer and also the energy efficiency. And these are some of the major projects he has been involved in. The second gentleman I got with me is Mr. Kai Polari. He has been with ABB. He's got master's degree. He has a global responsibility. He is a marketing manager for transformer, but he has a global responsibility for energy efficiency, or promotion of energy efficiency in the transformer. And he has worked in various different functions. He's member of T&D Europe, as well as IEC and Senelec. And I got master's in electrical engineering. I've been in transformer industry for 35 plus years, worked for ABB, GE, some of the global companies, worked in all functions. And I've worked with transformer manufacturers and suppliers as a consultant, and have been involved in the energy efficiency kinds of projects for various organizations in US. What we want to do is, first I will give you the global overview of regular MAPS, or minimum performance requirement. Then we'll talk about EU regulation. Professor Baghini will talk about that. And then Mr. Polari will give you how the regulation has impacted manufacturers. And then we will talk about what do we do about the future gains. We will have a summary and a discussion. Just to set the stage, what we are talking about is oil-filled distribution transformers, which come in all shapes and size, used globally. Primary buyers of those products are electric utility. The second product is dry-type transformers. That's also part of the regulation. And primary buyers for that product is industrial and commercial operations. And also, in EU regulation, we have power transformer included. And they come in small and a large size. And again, the primary buyers of that product are electrical utilities. Globally, when you look at globally, very many countries and many regions are looking at setting the minimum performance requirement for transformer. And that's the abbreviation MAPS. But they come in different flavor. Different countries are taking different approach to how they set the minimum requirement, minimum efficiency requirement, or minimum performance requirement. In US, the standards are set at the minimum efficiency at certain load. In EU, the distribution transformer, they specify the maximum losses the transformer can have. And for power transformer, they are looking at minimum peak efficiency index. Japan is regulating by setting up the maximum losses a product can have. But that regulation applies right now only to industrial customers or industrial users, not the utilities. India has, again, maximum losses, but they are specifying maximum losses at 2 different loads. And China, they have several different specifications, and they decide how many units they want to buy under which specification. So indirectly, they are also controlling how the efficiency or the gain in efficiency or gain in performance is introduced into the network. And many other countries have many volunteer standards. And in setting these standards or minimum requirement, what regulator is trying to do is they want to set the regulations such that it is possible technologically. It is possible to make the product technologically. They want to stay technically neutral, don't favor one technology over another technology, and it needs to be economically justifiable. So that's the mindset regulators have, and that's what they are trying to do. And what they factor in their decision-making process is first they look at what is the net present value of the energy saved by setting up new regulation. And they also factor in, it also offsets some generation. There is some capital requirement in setting up generation. They factor that in. Again, environment is important. They factor in emission reduction. They look at the cost of capital too, because you can always gain the efficiency at higher cost. So what's the cost of capital? Trying to balance that. And what they are striving for is the lowest life cycle cost. And they also factor in how the regulation is going to impact manufacturers and the users. And Dr. Bigini will talk about that too. What I've shown here is each one of those dots are specific transformer made from different materials. We have varieties of materials available, copper, aluminum, different grades of steel. And how does the product perform with those combination of materials? So each one of those dots are specific design. And what you generally notice is as efficiency increases, the cost goes up. So what the regulator is trying to do is trying to find the sweet spot. If you go too far to the right, the cost is too high. If you stay too far to the left, cost is low, but then the product is consuming too much energy. So that's what they are trying to balance. And this is just an example of globally what different countries are doing. The efficiency is shown on the y-axis, and the KVA rating is on the left axis. And there are a couple of outliers, but generally what you find is the majority of major countries are conforming to a ban within, so there is a broad ban of many different countries having the efficiency requirement. So at this stage, I'd like to turn over the stage to Professor Bigini.
Good morning, good afternoon. My scope is just to brief you on the European regulation on energy performances of large power transformer. Now it is. Great. So quite rapidly, the content of this regulation and the philosophy. This regulation entered definitively into force 1st of July of last year, setting minimum requirements in terms of energy performances of, let me say, all kind of power transformers. All power transformer purchased after the date of entry into force of the regulation. In 2021, the minimum requirement will be revised. And also now we are evaluating this revision of the levels. We have a long list of exceptions. This is the list of exceptions, but in my opinion, it's better to remember that it applies to all kinds of transformers. That is, a lot of exceptions, but each one of them is practically a detail. For example, instrument transformers or offshore transformers. So it's better to think in general. Let me say that the regulation is the best we have been able to produce, but it's not perfect. For example, we can discuss for months about some of these exceptions, like emergency transformers. We are defining them till now. Just some briefing for European and non-European citizen. What is a regulation? A European regulation is a European laws. That is, it applies directly to each one of us, of European citizen. This is different than a directive, because a directive is not a European law that applies to citizens, but applies to countries. And so, to have it on force, we need national laws. But typically, this take a very, very long time. And so, for hot topics, quite recently, we started with regulation. That is something produced in Brussels and directly valid for each one of us. This is the story of this regulation. The energy performances of transformer started at standardization level quite a long time ago, in '92. Then we had some directive, some new standard, and so on, till now, then when we have in place the regulation, as I said, and also a series of new European standards for the application of this regulation. To have this regulation, we had to reclassify the transformers. This can seem a bit academic, but it's very important. Why? Because this kind of regulation applies only to manufacturers. It's not possible for some strange reason to apply regulation to buyers. So just manufacturers are responsible. But the manufacturer does not know the application of the transformer. He knows just the product. So we cannot speak in terms of distribution transformers, because distribution is an application of the transformer. So we had to reclassify the transformers in three classes: small, medium, and large power transformers. I don't know anything about small power transformer. I know something about medium and large, and these classes are now defined on the basis of the rated power and the maximum rated voltage of the transformer. So the medium power transformer are these ones, and the large power transformers are the one in the white region. Some of them have been regulated in terms of maximum losses, according to the tradition in Europe since '92, and some other have been regulated in terms of minimum efficiency. Unfortunately, the boundary between losses, maximum losses, and minimum efficiency does not coincide with the boundary between classes. That is, small medium power transformer are regulated in terms of losses, large medium power transformer are regulated in terms of minimum efficiency. We decided to approach them in terms of losses and efficiency, and not all of them with the same metric, simply because it seems that would have been better for product, for unification of product, for flexibility to optimize large products, to have this kind of matrix. So now, just a few examples, a few minutes. Let's concentrate now on small, medium power transformers. That is up to 3,150 kVA and up to 36 kV. These transformers are regulated in terms of maximum losses, separated losses, that is no load and load losses, in terms of some tables. We have some allowances for special situations, that is, we refer basically to transformer between 1 and 1 and 24 kV. If we have other voltages and other details, we can apply some allowances of 10%, 50%, and something similar. The tables setting the minimum requirements are like these ones. These ones are the one for liquid immersed transformers. And now we are on the right, that is A0BK. In the future, we will move to the left. Something similar is for dry type transformers. Again, let me repeat, this table is referred to 1 and 1 and 24 kV transformers. Large medium power transformers, that is not fully large. This category in between. More than 3,150 kVA, but less than 40 MVA. These transformers have been regulated in terms of peak efficiency index, that is, in terms of efficiency, but not exactly efficiency, something similar. The equation is this one. We cannot spend too much time now on this equation. Let me say, practically, this equation is the efficiency we studied at school, out over in, but here we don't have the active power, but we have the apparent power, the apparent rated power of the transformer. This was needed because the active power flowing into the transformer is not in the hand of manufacturers. This is in the hand of the user. And the regulation has to approach the manufacturer and not the usage of the transformers. We consider that this, frankly, is a stupid political compromise. Also, the power consumed by cooling in no load operation is there. And this approach is good also for transformer requested to transform just reactive power. And so, after months and months of discussion, we decided for this metric. Practically, we measure the efficiency of the peak here for a given load factor. But we express it in terms of efficiency index. Let me repeat with the rated power on the bottom. The table of minimum peak efficiency index are this one for liquid immersed transformer and dry type power transformers produced in Europe. And large power transformer, that is the region on the right of my slide. This transformer have been again regulated in terms of minimum peak efficiency, but the difference with the other class was that in the world nobody never regulated this kind of transformer. So we started with a survey to know what was the level of efficiency, the level of energy performances of this kind of transformers in Europe in the last 10 years. And on the basis of this survey, we defined some level, that is this one, that frankly are not so aggressive. They are something reasonable just to be able to start. Now the level that applies are the one of tier 1, in this case on the left. In all the other tables, we on the right. Just to arrive to the conclusion, this is a revolution, and this unfortunately is theory. That is, we have to put in place, we have to control the market, and we have to leave also some tolerances to the market. The regulation set some tolerances, these values, about 5%, and we have the duty to control the market. This is a fully open sector, that is, the mechanism to control the market is not yet in place, even if a bit described in the regulation, and we are just starting now a project, this one, to help the market surveillance authorities to start for this project. Indeed, without control, the effectiveness of this approach will be reduced by 50%, 90%, something similar. That's all from my side now, and I leave the floor to Kai.
It is not only to improve the sustainability, it's also to stay competitive in the global arena of transformers, because it is also to maintain Europe's lead position in the technical leadership of transformer industry, because clearly the efficiency will be one of the aspects that the future competitive recipe is needing. So basically about the challenges, the big change that comes with the regulation is the fact that no longer the transformer performance is based on the agreement between the manufacturer and the purchaser. Now for the energy performance, we have a regulation which is setting the minimum requirement that must be met. And in combination with the zero tolerance for the manufacturer, this is of course a new situation for the transformer manufacturers and a huge challenge to be managed. And basically it's calling for of course availability of high quality and consistent materials, so much less scatter in the material can be allowed, because now the safety margin to make sure that the transformer is actually meeting the regulation has quite high price tag. And we need to make sure that in the end it meets really the minimum requirement. So it is really challenging from the transformer manufacturer's point of view, of course the design processes, also the consistency of the materials, as well as the manufacturing processes. And also we need to make sure that we can basically utilize in our designs and also in the manufacturing processes the best materials available in order to stay competitive in the global transformer arena. And basically what happens is that what used to be the winning recipe of the 70s and 80s is no longer valid today. And basically this kind of regulation, the nature of this kind of regulation is that it is basically driving also the innovation of the industry, and therefore there will be much more focus by the manufacturers on the engineering, on the technology, on the manufacturing processes, because that is more needed than was needed before the regulation in order to stay competitive. So basically, what are the basic methods to improve the efficiency of transformers? Is, of course, this very much simplified method is to use more materials, use copper rather than aluminum, and use the materials of higher grade, like higher grades of core steel in your design. And also, when the bar is going higher and higher, which will be the future trend, now we have the tier 1 in Europe. We already know the values. Well, it's not has been finally confirmed the values of the tier 2, but we know also the values of the future regulation that will come in force in few years. We need to also put more focus on things like insulation technology, how homogeneous insulation material is, the porosity of the paper, so it gets more and more complex. When we are going for higher and higher efficiency, the challenges in improving the level is getting higher and higher, and this is really calling for the support of the entire European supply chain of transformer components and materials. And what also is to be remembered that MEPS is only the minimum floor value that needs to be met by the transformer. We also, and this is also encouraged by the European Commission as well as the new IEC technical specification. The customers should utilize not only the minimum values which are stated in the standard, but also they should utilize the TCO concept to check whether it makes sense for them to go even for more efficient transformer. And basically our position as ABB, as one of the manufacturers, one of the leading manufacturers, as well as the whole European transformer industry, our position on this kind of regulation is that we are actually very much welcoming this kind of regulation to boost the European innovation and to prevent transformers with the lowest efficiency levels to be installed in the European network. So basically stop wasting energy and to provide more value for the user in form of improved energy performance. Then we are also promoting really the use of the TCO analysis also parallel with the MEPS regulation. And then the fact, like it was mentioned here already, that most of the manufacturers can easily meet the regulation. And in fact, ABB is able to produce transformers which are exceeding all the regulations globally existing today. And of course, ABB and the European industry in general, we are contributing also our knowledge in various standardization task forces and other means in order to drive the technology forward. And very much it's about, like I mentioned, it's about ensuring that Europe will maintain its leadership position, technological leadership position in the transformer the industry of tomorrow.
So the question is really, where do we go from here? It looks like the process of regulation is already occurring. Many countries are even revising what they already started. So standards are going to get tighter and tighter. And so we as an industry has a challenge ahead of us. And to meet future gains in regulation technology, technology is the solution to future gains in efficiency. We have to have either new materials, better materials, advances in materials, or better controls in processes. Like Kai mentioned that, the regulation has a zero tolerance. That says the supplier has to have very tight process control. Kai, you want to add something? How we are going to meet the future challenges?
Well, this is I think the main challenge is that, of course, when you are going up with efficiency, even the matters that used to be marginal start to play a bigger role. And how to handle all these different variables and aspects, that's going to be a challenge for the manufacturing sector, for sure.
Right. So you can always add material to gain higher efficiency. But what happens is the cost is also going up. So how do you control that? And by improvement in material processes and technology is how you are going to control the cost. And therefore, what you are looking at is, this is a technology curve, you want to lower the technology curve. And that's the challenge to the industry, is it's not just one person's ability to meet the higher regulation. It's going to require all material suppliers, transformer manufacturers, improving their processes, and equipment manufacturers, providing better equipment to transformer manufacturers so they can control the processes and product cost.
Yeah, like it was mentioned, most of the manufacturers can reach these kind of levels of efficiency. The question is, who is able to do it with the least marginal cost and stay competitive? And that may change the competition environment of the whole industry quite considerably.
So I think in summary, again, the major economies have started maps. EU has gone further, and they are setting the regulation both for distribution and power transformer. Many countries have even amended their initial regulation, like Department of Energy in USA, and many developing countries are also taking leads from the developed countries and setting up the regulations. So far, manufacturers have been able to meet that challenge using the traditional materials. But for future gain, again, what's required is the new material and new processes and new equipment. And now I will open to any questions anybody have, to any of the panelists.
You're talking about new materials. Basically, we talk about no load losses first. I'm from the transformer industry only. The mainly available materials are just CRGO and amorphous. Apart from these two, are there any other material available?
Okay. What you are describing is the core material.
Yes.
But what about the insulation, the type of insulations? Because insulation is somewhat a dead space within the transformer. If there is a better grades of insulation available, which can operate at high electrical stresses, then you can reduce the thickness of insulation to, again, reduce the size of the transformer. So we are not talking about just core material. I think we are looking at all materials used within the transformer, which the improvement can occur to shrink the size. So
you are speaking about amorphous, but do you really think that amorphous could be a solution for the future? The amorphous steel.
Yes.
For sure, it could be a solution. What I can mention is, from the point of view of regulation, we tried to set up a minimum level reachable with all existing and known technologies. That is feasible also with other technologies. Probably amorphous will be one of the best solutions for the top level.
And I can comment also that basically the policy of the European Commission is to make sure that the interests of small and medium-sized players are also protected. And basically we have tens of small manufacturers in Europe which are not ready to shift in, in short notice to another technology because you need to have another invest on manufacturing machines as well. So they want to make sure that the play field is equal and it's reachable for the existing players to the large extent. And also what is happening between, if you compare the grain-oriented and amorphous is that there is all the time improvement with the grain-oriented steel. So the gap between the grain-oriented and amorphous is actually closing, which is, this is how the competition is functioning in its best way. But it can be, I think it's the state-of-the-art level is amorphous, which is also now, there's a reference in the new EN standard AEEE 0. This is basically amorphous reference level for no load losses, but it's not mandatory to be met.
What do you mean by the closer coupling of the core and the coils? I'm asking from the core manufacturing side.
Well, I'll give you an example. Typically, the low voltage winding in transformer is using the sheet aluminum. And if you really look at it, the insulation used between the tons is there for mechanical reason. It has to be certain thickness to be able to withstand the mechanical stresses, not for electrical reason. So in fact, there is already development occurring in that area where you can have a thinner insulation which is tougher and can withstand the mechanical abuse, so to say, in the manufacturing process. And that allows you to then shrink the low voltage winding size and the size of the transformer. So that's the one kind of material improvement that can occur. The another one that can occur in coil winding, that if you look at the wire many times is round wire. There is some space wasted between the tons. So by shaping the conductor, you can make the conductor come closer and tighter. So again, shrink the coil sizes. That reduces both losses and the cost too. So those are some of the challenges that industry has in trying to go up on the efficiency curve. Is that helping?
May I add something you already said, frankly, that is also the process. As much as the company is able to control its process, as much it can take the risk to stay close to the target. If the process is out of control, you have to add tolerances, and this is still applicable to the core as well to windings.
Regarding amorphous steel, does that mean that the transformer gets bigger, as far as understood? And the other question would be, I don't think that the utilities are happy with that, especially when they have to change a transformer in an existing station, or in the future they have to build up larger transformer stations.
Yeah, it's amorphous transformers. I'm not saying that they are very much larger, but they have different kind of dimensions. So one of the dimension may be increasing. And then typically you may have a little bit higher noise level. This is what is happening. But in maybe you can comment on this, but in creation of the levels of the regulation, all these aspects have been taken in account. And in fact, for instance, with the weight issue of the pole-mounted transformers, they were given a longer time to adapt. And of course, the utilities have been a stakeholder in the process when creating the levels.
Yeah, I am fully with you. That is, these levels are a compromise, nothing scientific, just a compromise of months and months of discussion between stakeholders, including utilities. Let me say that probably manufacturers were a bit more hard than utilities. So I suppose that this kind of issues you pointed out are existing, but manageable by utilities, yeah, because they were happy.
And of course, this is not coming out of the blue. The process started a long time ago, and there was a time to adapt, and now we will have tier 2, and there is a time to adapt also for that one. So like I said, this is really driving the innovation. So the industry is giving this kind of challenge. We have this constraint, we should be able to produce the transformers of the equal size as before. How can we do it? And I'm sure that we have not in the end of the technical evolution there. So I'm sure that solution may come up.
Thank you. In the event that a transformer is repaired or refurbished and it needs to return to service, does the European regulation cover older transformers that then needs to be repaired or refurbished?
Yeah, I understood the question. I think basically for refurbished transformers, the regulation is not
Clear.
well, they are basically outside of the regulation.
Yeah.
But if you modify the transformer with its main rated value, like increase the rating or change the voltage level, then basically the interpretation of some surveillance authorities that I know is that it becomes like a new product and it needs to be compliant with the existing regulation. But if it's an old transformer, you just refurbish it and put it back to the service, that's okay.
Yeah. Formally, this boundary is not yet fully clear and written. It will be cleared in the first amendment of the regulation, basically in a couple of years.
Yes.
The concept is this one.